Hi, hello to everyone. This is Dr. Satheesh Kumar, working as the Associate Professor in the Department of Information Technology at the Institute of Aeronautical Engineering, Hyderabad. So, in this session, I'm going to tell about ASR's algorithm in artificial intelligence. Okay, so previous session, just we have seen the BFS algorithm, breadth first search algorithm, and also the greedy method. So, in this video, just I'm going to tell about the A search algorithm. Okay, A star search algorithm. So this is also one of the type of informed search algorithm and artificial intelligence. So the second type of informed search algorithm. Okay, so how it will be? The yes or search algorithm will work on the artificial intelligence machines. How it will be solve some critical problem. How it will be give us some optimal solution. Either it is optimal solution or actual solution. Finally, we will check with some example. Okay, so in this video, just I'm going to tell about the definition of the A-star search. What is the definition of what is the A-star search? How it will be? Why we are going for A-star search instead of some other algorithm? So comparison, everything. Okay, the next one is the algorithm. So algorithm of the A-star search algorithm. Then finally, just we are going we move to example of A-star search algorithm. Yeah, let's start. So what is A-star search algorithm? Okay, so it is one of the informed search algorithm in artificial intelligence algorithms. Okay, so A-star search algorithm find the shortest path. Okay, so it will use to find the shortest path in your given graph. Okay, either it is a directed graph or undirected graph. Just we are going to find the shortest path. Okay, so A-star algorithm is find the shortest path through the state space using the heuristic function. Okay, so the BFL also just we have used some heuristic function. Okay, here in the A-star search also just we are going to use the same heuristic function to find the shortest path and the distance of the each and every node. Okay, so what is the final goal? Just we have to reach the source node to a goal node. Okay, so for that just how we are going to find the shortest path. Okay, using the A-star search. Okay, so the what is the second point? It uses a heuristic function. Okay, so in the BFS already said that BFS also just we have used the heuristic function. Okay, here additionally just we are going to use some cost of the particular node. Okay, that particular selected node. Okay, best node. Okay, so here we use h of n, the heuristic function, and the cost to reach the node from the start node. Okay, so where we are going to consider the source node to the some other node. Okay, so that cost just we are going to consider to find the shortest path. Okay, so for example, just here previously just we have some n number of nodes, right? Okay, like this. So here just we are going to each and every node we have some heuristic function. So based on this heuristic function, just we are going to find the path between the these nodes. So here this what we are going to just we have some cost. So cost of each and every node. So here this we are going to use that cost along with that heuristic function to find the shortest path. Right? So h of n. Okay, here some right. So I'm writing the formula for h of n, g of n. Okay, so the h of n is nothing but that heuristic function, the given heuristic function based on your trees. Okay, so g of n is cost of from cost from your goal node. Okay, so that is the the starting node, so starting state of your node. Okay, that's the value of the cost of your starting node. Okay, so that is g of n. Just I will tell you that what is the h of n and g of n. Okay, so this algorithm expand less search tree and provide optimal result faster. Okay, so if you are using that A-star search, we no need to visit all the present nodes in your tree, right? So if you are selecting the shortest path, the best path, okay. So if you are goal node, this means just we are going. It will select the from here to here, from here to here. That's it. If you are reaching that the goal node, then it will produce. It will give that solution. So optimal solution. So it is called the optimal solution. So fastly it will provide the result. Okay, so that's the meaning. Okay, the next one is it is similar to UCS. Yes, UCS means just already unique a unified cost search. Okay, unified cost search. UCS means unified source cost search. Okay, so expect that it is G of n and H of n instead of G of n. So in that unified cost search, just we know all the concept of the UCS array. Just we are going to consider the numbers, that value alone. Okay, for example, just a heuristic function is there. That function only, for example, in BFS we have taken only heuristic function. So MS the unified cost search also, just we are going to take only that values. Okay, but here in ASR search, additionally, just we are going to take the cost of the starting node. Okay, so only that ASR search it will similar to the unified cost search. Okay, here we are going to consider values. ASR search, so we are going to take values of UC function and cost of starting node. Okay, so values we are going to take. So only that so ASR algorithm is always similar to the UCS. Okay, so here next ASR search UST case value, the cost reach node, hence combine the both cost as. Okay, so if you are finding that the shortest path between the nodes, okay, so we are going to consider the USC function of the particular node and the cost of the starting node. Okay, so that just we are going to write f of n equal to g of n plus h of n. Okay, so here just in this formula, just we are going to consider some values alone, right? So simply it will call as the fitness number. So simply that ASR function algorithm function, simply we are going to call a fitness number. This one is important, right? So fitness number of ASR means f of n equal to h of n plus g of n. Okay, here see, so what is the f of n? Estimated cost of the cheapest solution. Okay, already said it will produce the optimal solution very fast, right? So f of n is the estimated cost of the cheapest solution. Okay, just we are going to find the function, we are going to find the value, we are going to find the shortest path using the particular function and value, right? So that's g of n, the cost to reach node from the starting node, right? So for example, this is A, this is B, this is C, right? So now we are going to take the cost A to B. Okay, A to B means what is the cost of the starting node or starting state? This one, 1. Okay, so now just we are going to take the cost of the node A to B means 1. The next one is a heuristic function. So separately from each and every node, based on the state, that we are going to assign some heuristic function. Just while I am telling that example, I will tell you what are the value for each and every node. Okay, so here manually just we are going to assign some value for each and every node. That is heuristic function values. Okay, so this one is my ASR search definition, and why we are going for ASR search instead of the other search techniques. How it will be produce the optimal solution. Right? Clear, right? Okay, next just we will move to the algorithm. Okay, a short search algorithm. Okay, just keep in mind the previous section just I said to the BFS search algorithm, right? So it is a little bit similar with a search algorithm also. So first two steps is the same as the BFS also, right? See here, what is the step 1? Place the starting node into the open list. Just we have a open list and close list, right? So we have to list before we are starting to solve some particular problems. So what is the first step? Place the starting node. Just if it is A is a starting node, just we have to keep in the open list. Okay, into the open list. So check it is open list is empty or not. Stop the return failure. Okay, so what is the step 2? Just we have to check always the open list should not be empty, right? So already A is here. Just while we are starting, there's some nodes we are going to be enter into the open. Okay, when we are going to select the particular value, okay, after comparison B, so either we are going to compare both the values, which one is lower, then that value going to be added into the close, then we will remove the that node B. So we have to ensure that just always the open list should not be the empty. Okay, if it is so, we should stop and that we have to tell that the system has a failure. Okay, so that is a step 2. Okay, the next one is step 3. Select the node from the open list which has the small value of evaluation function. Right? So if you are using that formula g of n plus h of n, okay, so from the starting node to successor node, we are going to calculate the value using this formula, right? So then after that, just we have to compare the both the values. So which one is smaller, which one is a less value, that value we are going to select to proceed the further. Okay, so that is the step 2. Select the node from the open list when has a small value of the evaluation function is. If node n is a goal node, then return success and stop stop. Okay, so if you are following the steps until the reach the goal, okay, just we have to give the success to the machine. Okay, or otherwise just we have to follow what is the step 4. Okay, so if you are not the original goal node, okay, then again we have to compare the values. We are smaller value we are going to take, that value that node going to be considered as a source node or starting node, right? Then otherwise just we have to expand the node. Okay, expand the node n and generate the successor and put into the closed list. Okay, again just we have to expand that one. Okay, which one we are going to take this from the smaller value, that we are going to put in the closed list. Okay, so for each successor n, check whether it is already in the open or closed list. Just before that move into the closed list, just we have to carefully check into the particular node are already presented in the either open or closed list. Okay, if not, compute evaluation function for n and place into the open list. Okay, if it is not consider the previous, now we have to consider that particular particular node as a starting node. Then we have to take the successor node of the particular starting node, and we have to calculate the value using this formula, and we have to put into the open list. Okay, that one the second one. Oh, there's the next step. Okay, else if node is already open or closed list, okay, then it should be attached to the back pointer which refer to the lowest cost value. Right? So if it is open or closed list, the particular node we have to evaluate. We have to evaluate the particular value of starting node cost value and heuristic function. Okay, then if it is so, just we have to give this a back pointer. Okay, if we have to put the back pointer, and we have to calculate we have to compare the lowest value. Right? So that is the step 5. This is the final stage, final value of final procedure of to reach the goal node. Okay, then if it is so, then we have to return to the step 2. This step will be occur while you are calculating a function value and the cost of the value. Then we have to proceed the second step. From the second step, right? So this is the algorithm. This is a set of procedures. Just we have to find the shortest path between the given tree. Clear, right? The next one. So next one is the advantages and disadvantages of if you are using the A** search algorithms, right? So what is the advantages of if you are using A** algorithm to find the shortest path for a given graph? So it is a best algorithm than other search algorithm. Just we will tell that it is a best algorithm. Okay, so A** search algorithm is a best algorithm comparatively to other search algorithm. Why means it will produce the optimal solution. Okay, best solution and complete. Okay, just previous section I said the BFS is incomplete because each and every node it can't visit. Okay, only it will see the shortest path to reach the goal. Okay, here it will produce the optimal solution based on your A star search algorithm performance. Okay, then it will be complete to one. So it is your best case. Okay, it will come under the best case, right? And then actually it can solve very complex problem. Okay, it can solve very complex problem. Okay, not only the small problems or medium problems, just moderate problems, it will solve a very complex problem. So these are advantages of A star search algorithm. So what is the disadvantage of the A star search algorithm means it does not always produce the shortest path, right? Okay, so just after finding the value of h of n plus g of n, if we reach those goal node, then we can't go further nodes. So it will always not produce the shortest path. It is not practical for various large scale of problems. Okay, so if you're having the heuristic function, the cost of the starting node, just we can easily calculate. Okay, if you're having a large value of from the particular nodes and a heuristic value, it is very difficult to find. Okay, practically it is not possible to find the all the possible values. That is both advantages and disadvantages of A star search algorithm. Okay, the next one, just we are going to see one example, right? So just I will draw the a diagram of A star search algorithm. Then you easily comes to know the what is the how we are going to solve the particular problem. So consider this is here some graph or directed graph or a tree. Okay, one tree. So just here we are going to assign some value of some cost of each and every node. Okay, just we are going to assign. Just we are going to take all the cost value from the between the nodes. Okay, so here just we are going to write the heuristic function of each and every node. Okay, so here yes, A, B, C, D, G. Yes, A, B, C, D, G. Okay, so each and every nodes we have some values of heuristic function value. A, yes for S 5, for A 3, for B 4, and then 2 6 0. Okay, like this just we are going to assign the heuristic value for the particular states. Okay, so here and now just we are going to find the shortest path to reach the particular goal. Okay, so see this one, G is a goal node. Okay, now just we have to reach the from starting node to goal node. Okay, so just S is a starting node. Just we start and node. Just we have to consider this one is here the starting node of the given graph. Okay, so what is the formula here? Just f of n here, g of n plus h of n. So this one is a formula for finding the all the values between the nodes. Right. So what is the first step? What is the first step? Just we are going to calculate the value. Okay, just we are going to consider the starting node S. Okay, so this one is a starting node. Okay, so from the starting node, how many successor is there? One, 1 and 2. Okay, 1 and 2. 1 means that from starting node S to A, then from starting node S to G. So two successor nodes are there from the starting node S. Okay, so now just we are going to consider S2 first A, S2 A. From this we are going to calculate f of n value, f of n value, right? Function of heuristic value, right? So here just while I'm telling that algorithm, just we have to consider the open and the closed list. Okay, but we no need to write a open list and a closed list like a BFS. Okay, just we are going to calculate the values. Okay, only the values from the given problem. Okay, so after that just we have to compare the both the values from yes to successor is there. Then two successor value, which one is the lowest, we are going to consider the next starting node. So if it is so, here just we are using that open and close concepts indirectly. Okay, so what is the formula? F of n equal to g of n plus h of n. So what is the g of n? Starting node, the cost of the starting node. Which one is a starting node? S. So cost of the starting node A to S. Okay, what is the cost of starting node S? 1. Okay, plus what is the heuristic function of h of n? Value of A this one. Okay, 3 equal to 4, right? So the next first successor is S2A. The second successor is S2G. Okay, now again we are going to same f of n. Okay, so S2G. Okay, so what is the G, starting cost of the starting node? Value 4 plus. So now just we are going to calculate get the value of heuristic function of G. What is the sorry, just you have to consider a 10 something. Okay, so here what is the value of this one is 10, right? So cost of the starting node or node of S2G is 10 plus what is the value of G, heuristic function of G? 0. So the total value is 10. Right, now just we are going to use the open and close list. Okay, here open and close list means open A comma sorry S comma A comma G, then close list simply yes. Okay, starting node just we are going to take this one. Next we have to compare the both the value. Okay, so if you are comparing the both the values of the function is, so which one is a minimum, just we are going to consider the minimum value. So for minimum value is 4, then 4 means just A, right? So A is the minimum value. So here this one just we are going to give the hold. Okay, just we are not going to remove from the list, just we are going to take hold on the particular path. Okay, this path just we are going to keep on hold. Okay, we should not remove. Okay, then next next value just we are going to select the A is the starting node. So A is the starting node. Okay, from the S. Okay, from the S, right? So here just now we are going to write S comma A like this. Okay, no need to write this the open and the close this. Just keep on mind for betterment of understanding. Just I'm writing here. One BFS just we are going to take. We are carefully we have to see that open and close list. Okay, here just we are going to use this formula. We are calculating. Okay, no need to do further. Okay. Now then again the second step. Then we are going to consider that A. Okay, so from the starting node A, how many successors are there? 2, B and C. Okay, B and C. Okay, now just we are going to take S2A and SBA to B. Okay, so from here just we have to consider from here S2A and A to B. Okay, that is a starting node, right? So because we are a source node, for example, just you consider this one is source node. Then now it is starting node is A. Okay, so from the source node only, just you are going to calculate the cost of the cost value, right? So now here just we are going to calculate the f of n value. So what is the first g of n, the cost of the starting node 1 plus 2, okay, 1 plus 2, then what is the heuristic function of b4? So what's the value, total value 7, right? The next one is S2A, A2C, right? So what is the cost value, A2, S2A, A2C, 1 plus 1, 1 plus 1 plus, so what is the heuristic function of C? 2. Here 1 plus 1 plus 2, 4, right? So now we have calculated the second starting node. Okay, so now we have to compare. Okay, so this one is 4 1 is smaller. Okay, then here the 7 we should be keep on the hold. Okay, next one, what is the third step? Now just which one we have selected? C. Previous is A. Now in open list is C, right? So this should be, we are going to select the C, node C we are going to select now. So from the node from the C node, how many sorry, here this we should keep, here we should keep, okay, sorry, then from C, how many successor is there? 1 and 2, right? From the starting node C, these two successors are there, C2D and C2G. Now we are going to consider S2A, then A2C, then C2D. Then we are going to calculate function of the starting node S2C. Then 1, 2, 1 plus 1, 2, 2 plus 3, 5, 5 plus. So what is the heuristic function of D6? Equal to 11. Then next one, A2A, S2A, S2, A2C, C2G. Okay. So what is the function that we are going to calculate? 1 plus 1, 2, 2 plus 4, 6. Okay. So 1, 2 plus 4. Okay. 1 plus 1, 2, 2 plus 4, 6. Okay. 6 plus, so what is the value of heuristic function at G? 0, 0. Okay, so total value is 6. Okay, now just we are going to compare. Okay, so this one is 11, this one is 11, and this one is 6. Now we are going to consider 6. So this path just we are going to do on the hold. Okay, now just we are going to select the 6 as a minimum value. So here already we have set the goal state is G. Okay, so now we have reached the goal node at G. Okay, so what is the cost value? 6. Okay, so what is the shortest path? S to A to C and G. So what is the cost here? 6. Okay, so just we are going to calculate both the cost and the shortest path of this graph. Okay, so like this, just we are going to find the shortest path of the given graph or a tree. Okay, so it is produce the optimal solution. Okay, both the cost and shortest path. So this optimal solution, it is a completed one. Okay, so after finally shortest path and cost also, just we have find. Okay, so it is called as completed one. Okay, so the next one is just these are the textbook and the references and the web references. Just I'm going to use to prepare in this slides. If you have any doubts, just you can go through this one. Okay, so from the next by the next class, just we will see the new algorithm in artificial intelligence. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.